Welcome to Uncle J class. If it's your first time of watching my channel, please hit the button subscribe so that you'll be getting my subsequent classes. Yes, last time we started log reading lesson 1. Today we are going to do log reading lesson 2. We were able to introduce it and some of the rules that go with it. Today we are going to solve something like log 5 root 5 base 5. Log 5 root 5 base 5. How to go about this is log 5 base log 5 root 5. Root 5 is the same thing as saying times 5 raised to power 1 over 2. Root 5 is the same thing as 5 raised to power 1 over 2. And the law of indices say that when two numbers of the same base is multiplying, you add the powers. So what we now have is log 5 is the same thing as raised to power 1 times 5 raised to power 1 over 2, all in base 5. So this will be equals to, we are adding the powers, 5, 1 plus 1 and a half, all base 5. So by the time you add this or do the LCM, which will give you 5, LCM is 2. 1 divided 2 is 2. 2 times 1 is 2. 2 plus 2 divided 2 is 1. 1 times 1, 1. So you now have, what you now have is equals to 5 raised to power 2, 3 over 2. So you come here, log 5 raised to power 3 over 2 base 5. Okay? This simply means 3 over 2 log 5 base 5. And any log to its base is 1. So 3 over 2 times 1 equals to 3 over 2. This is how to go about solving such problem. We are going to take example 2 so that we will know how to go about it also. Now we have studied the law, we are now applying the law. Log, number 2 question here say log root 25 base 5. You know, the previous one we did was the root. For us to remove the root, we power it into to the power of 1 over 2. So this thing simply means log 25 raised to power 1 over 2 base 5. And you can add, there's 2 ways you can solve this. Let us use this way first. We can now reduce this to be 25 is the same thing as 5 raised to power 2, okay, multiply by 1 over 2 base 2. This will give me, when you multiply out, when you cancel out, you are left with the log 5 raised to power 1 base 1, which is 1 log 5 raised to power 5 base 5, 1 times 1, which is equals to 1. Alternatively, we can also solve this problem this way by saying log root 25 base 5. Just find root 25. Root 25 is 5, then base 5. And 5 is the same thing as 5. 5 is the same thing as 5 raised to power 1 base 5. So log 1 will be equals to 5 base 5. Log 1 times 1. Then 1 times 1 will give me 1. So whichever method you use, you will arrive at the same answer. Let's look at the third, third problem here. See how to tackle such problem. The third problem says find y in if log y base 9 equals to 1.5. Find y if log if log if log y base 9 is equals to, when anytime there's equality sign, a log is equated, the base will be raised to the power of the equality, the power of the number that is equated to it. What do I mean? It become log y will be equals to 9 raised to power 1.5. So whatever you solve out is y. So y, immediately you raise this to power 9, you have this log has no base again. So y will be equals to 9 raised to power 1. I want to make it a whole number by saying 15 over 10. To remove this decimal point, since you are moving to one decimal point, it gives you 10. It becomes 15 over 10. So if you reduce it, 9 raised to power 15 over 10 is the same thing as 5 go 2. 5 go here 3. The same thing as 9 raised to power 3 over 2. So y will be equals to 9 raised to power 3 over 2. Actually, with the rule of indices, we can actually reduce this 9 to be equals to 9 is the same thing as 2 raised to power 2 times 3 over 2. When you cancel that, you are left with 3 raised to power 3. So y is equals to 3 raised to power 3. Or you can even simplify further by multiplying that. So y is equals to 27. This is how to go about it. Thank you.